How you doing, guys? Today we are starting the reassembly process of the Clinton 1290, B1290 specifically. As you can see, I honed the block, I cut the valves with my New Way tool, and I lapped them in. So all that stuff is done. Right now, I'm just about to go ahead and set the valve lash. But for you individuals that like the numbers, the measurements for a few things is like this. When it came to the crank is in two directions. This would be the thrust direction. This would be the non-thrust direction, the B line. And we're working out to be roughly 0.910, 0.910. So it's a little bit small, or it's a little bit on the smaller side, let's put it, because the spec is like 0.914, so 911 to 912. We're like more like 910. So the crank is a little bit worn, but at the end of the day, there's not a whole lot we can do about that. There are no real options with the crank. We could have it turned down, I guess, and put a smaller rod, but the smaller journal rod becomes an issue because they're hard to find, if not no longer available. Like, you just can't find them. On the bore side, after honing, we're at 2.469 to 2.470, somewhere right in there. It's supposed to be 2.4685. So we're just a little bit big to 2.4695. So, we're 247. So we're on the higher side when it comes to the bore, but again, not a whole lot we can do about that. The hone came out pretty good. There are a couple scratches in the bore. Let me just turn it around a little bit. You can see, yeah, there's a couple little scratches in the bore right there. And I didn't really want to go bananas crazy honing this thing like mad, because I just didn't want to open it up any more than it was. So for the valve lash, I have the cam pin is just started. The cam is in there. The lifters are in place. We're at basically top dead center, so that way they're in the neutral position. The lifters are all the way down. I did clean and obviously lap the valves, intake and exhaust. And when we take a look at the numbers, where is it? Valve clearance. Oops, here we go. Valve clearance, intake, and exhaust. And the interesting thing about a Clinton is they're both set to the same amount. And this third column, column 13 is the one that we want, and it's 9 to 10 thousandths each. Right now, with the valves dropped in, I can't even get a 9 thousandths in. So I'm going to go ahead and set up the grinder and lightly, very lightly, grind the end of the valve to get us to it. I'm hoping like 9 thousandths. That's what I'm hoping to get to. So I'm going to have to be real careful and take my time to dial those two clearances in. With a little back and forth between the grinder, the file, the sandpaper, I was able to nail the lash on both valves to 9 thousandths. It actually fits really good. I'm trying to do this one hand. It's not going to be easy, but yeah, I mean, trust me, it's 9 thousandths. I even wrote it down on the card, so it's all set. Next up, let's go ahead and get a set of rings, replacement rings for it, and we'll put them in the bore and see where our end gaps are. I have a standard re-ring kit here for a Clinton 1290. It's one of the chrome style rings, and it has like a standard oil control ring with the two oil control scraper rings. The expander ring has a series of rings for the middle and a top ring, all to work on a standard piston. The manual, when we take a look at it, where is that on this thing here? Crankshaft play. I just had this too. I don't. Oh, ring end gap, right there. It's an amazing. It's 7 to 17 thousandths. Clinton was real specific, you know, like real tight tolerances. On this motor, it's running 17 thousandths. That's because we got wear in the bore. I had to hone it. You know, if we used the 10 over ring set, we could go ahead and dial in the end gaps to a little tighter, you know, make it more close to like 11 thousandths, but I don't have that luxury. I have a standard ring set here. I probably could look for a 10 over ring set, but this is going to be fine. I'll just, when I put the piston in the bore, I will make sure that the ring end gaps are staggered really well. This engine's not going to get worked every weekend for the next 20 years to mow the lawn. This is going to be an engine used to putt around shows on an RJ35. So with the valve seats tightened up, with the rings put into place, this and a new hone, this engine will be just fine for that. So right now we're going to go through major league cleaning, spraying the block down, blow the block all off, get that thing all set for reassembly. Same with the piston, same with the camshaft. We're going to put a new rod in it, so that's going to be all set. And just to get everything dialed in and ready for reassembly. So let me go through that and I'll be right back. All right, the main components are clean and ready to go. The bearing plate's good, the bearing's clean, everything's all done, both sides. Both sides of it are all clean, got all that dirt and crap off it. The cam is ready as the pin and the governor slide just need to do a last second wipe down. Tins are in good shape and ready to go. Piston is completely cleaned. Just needs the rings installed, so we're set there. I do have to clean the pin and the keepers. The block is set, cleaned, ready. Cleaned all the valve guides. Everything there is all set. If we take a look at the inside real quick, inside is about clean as it needs to be. Everything has been taken care of, so I'm real happy with that. I'll just go ahead and tip this back up real quick. The head is all clean. I chased all the threads. Then I also surfaced it, and when we put it up here on the engine or up on the block, and you know, I go corner to corner, there's no rocking, no noticeable rock in the head, so that means like almost close enough that the head and the deck of the block are parallel, so there's no issues there, which I'm happy about. The crank cleaned up very well, sanded everything, chased the threads, got the key out, got all the rust off, cleaned all the bearings. That's all good. Went ahead and cleaned and polished the journal, so that's all set. So I'm just about ready to start putting this engine together. First up will be rings on the piston and the rod on the piston. First thing I'm going to reinstall is the valve train. Basically, a Clinton is pretty simple. One thing I got to say is when you look at a Clinton motor and like a 1200 like this one versus a K91 from a Kohler, or the K90 for that matter, they're almost identical. I mean, there's really just a little bit of a difference between the two of them. I mean, when you look at them from this perspective, they're laid out exactly the same. The intake is on the right hand side as you look at the motor in this fashion. The exhaust is on the left. You have a standard bore. Yes, the bore is a different size, but in general, you have the bump out for the cam. Your governor's in the same spot. I mean, the valve train is laid out the same. The cam is laid out the same. The crank is laid out the same. Heck, it even has a bearing plate that's very close to the same. I mean, all right, so maybe the Clinton has a tapered roller bearing in it compared to a straight, standard roller bearing. They both have head tins. They both have bore tins. The carburetors can actually be swapped between the two makes. So, I mean, And then, you know, standard seals, you know, essentially they're the same motor. Now, I think the Kohler itself is a better design or a better motor for whatever reason compared to a Clinton. Clinton had always had issues with quality of parts. But the one area that I think the Clinton excels over the Kohler is the valve train. And what I mean by that is this. This is all the parts that you need, that's in a 1200 Clinton, okay? And one of the things that's a big difference between the two makes is instead of the valve stem being drilled or a hole in the valve stem and a small little pin being placed into the valve stem to hold the spring retainer in place, okay, basically like that, okay. Clinton has a groove in a C clip or a C style clip that slides in. Then the retainer sits down on this clip by the spring pressure. I find this particular design superior over the Kohler because the little tiny pins take a beating. And like when I was doing the grab bag Kohler, you know, I had to hunt and pick for a good set of pins because they're all bent or they're you know, beat down on one end. While most of the time a Clinton, the clips are in good shape. You know, they're usually not destroyed because that load is being applied to basically almost the entire you know, diameter of this clip because it goes all the way around this ledge. So that's just one of those things where I think the Clinton is superior to the Kohler. Installation is exactly the same. Drop the valve in, flip the motor over, compress the spring, put the retainer in place in this fashion, like this, you know, like it goes like that in the motor, but when the motor's upside down, it's going to go in this place. Compress the spring. Once you have enough room, you just take your little clip, you put the clip right there, you release the pressure, the spring holds it all together. So I'm going to go ahead, put a little bit of bearing grease, like I always do, on the stem, install the valve, compress the spring, put the retainer and the clip in place, and the intake will be in. I'll do the exact same thing to load the exhaust. Right after putting the valves in, I went ahead and loaded the piston with the rings. Just used my ring expander and just carefully dropped them on. Now this is a re-ring kit. Clinton put these kits together for exactly this purpose, engines that have some wear in the bore. So there's an expander ring, then there's a chrome ring, then there's a chrome ring, there's the oil, there's 4 rings just for the oil control ring. The second groove has 3 different rings in it, and then the top compression ring has 1. Now there is a set way to do it, and I just followed the directions. Oil control, middle, top. The top has the groove up or the bevel up. The scraper groove goes down, and then there's just a series. And they tell you exactly how to do it. So piston is loaded and ready to be installed. Before we do that, we do have to put the cam in and the lifters in. So we'll be doing that next. Actually, just before we put the camshaft and the lifters in, I do have to put the governor in, or the governor arm. This little arm actually sits in this position in the block. We got to send this in through the bottom of the block, through the little hole, and we do have to put the bushing in place. The one thing about this is, unlike a Kohler, which won't necessarily fall into the block, this one will. At some of these motors, it will have the ability to fall in the motor, and that's a real nightmare because you got to pull the pan, you got to take the cam out, you got to get all that stuff out of the way in order to get this back into place. So I'm going to go ahead, put this in, clean the cam, the pin, and start putting that in also. In order to get the governor slide back on the camshaft, there's this peg right here which has to interface with this little half moon cutout. So what I'll do is I'll actually lay the cam, all these little weights have like this little U shape, that has to be inside one of these, inside this edge. So what I'll do is I'll usually lay the cam down on the ground, lay it in this position. I'll drop the slide in position like this, okay? So the knob, the notch is in line. And then essentially I'll just pull it up like this and then just flip the cam over and then just let it slide enough till all the weights kind of drop into place like that, okay? And then just push it back up. And then usually on the first shot, just like that, the weights will be back in. The governor rod, which I just installed, rides along this edge because these weights flip this out, and that's what actually actuates the governor. I have the cam installed. The pin is pressed in, or I just tapped it in with a hammer, so not a big deal. The only thing about the Clinton engines compared to a Kohler is the pin actually goes from the PTO side to the bearing plate side, unlike a Kohler, which goes from the bearing plate side and presses into the PTO side. The other little interesting tidbit with a Clinton is Clinton always had this little pressed-in plug, which kind of goes over, fits in on the PTO side. And what this is to do is to keep oil from migrating out of this hole where the pin goes in, because this is slip fit, while this side is press fit. So in theory, oil won't leak out of this side, but oil could migrate out. You'll see a lot of people not replace this plug. These are usually missing if somebody's rebuilt the engine, because one of the big problems is somebody will take this pin, or with the plug at the end of the pin, and press it all the way through the camshaft. Now you got to remember, this thing is a little bit bigger than this hole, which is a little bit bigger than the cam diameter where the pin goes. So you can actually crack a cam by forcing this thing all the way down through the cam. So when you take this pin out, the first thing you do on a Clinton is you push it, you have to push it this direction. The plug should pop out and then the pin. It's just one of the little nuances about a Clinton. The pin goes from the bearing plate side to the PTO side. Next up, we're going to install the crank. I have rotated the camshaft in a position where at least the timing mark is close. It may not be exact, but we do have a very small timing mark right there on the crank gear. Now you can get this bearing past the big gear of the camshaft. It's a little tricky, cumbersome, but it can be done. One thing we're going to do before we do anything is we're going to go ahead and lubricate this roller bearing with assembly lube. So that's all set. And then I will go ahead and snake it in there and line up our timing marks. The timing marks are lined up. It's a little difficult to see, but the dot on the tooth and the dot on the cam gear are lined up, so that's good. Next up is installing the bearing plate. I don't have one of these gaskets in stock, unfortunately, so I measured it. It's 30 thousandths. I do have 30 thousandths thickness, that is. I do have some gasket material that is 30 thousandths in thickness, so I'm going to make a paper template of this and then transfer the paper template to the gasket material, cut the gasket out, punch the holes. You've seen me do things like that in the past. No big deal. And that way we can put the gasket right here and we can bolt the bearing plate in with the 1/4 bolts according to the manual. When we look at the bearing plate to block, where the heck is it? There it is, bearing plate, flywheel end is actually 140 to 160 inch-pounds. So that's what's next up. I'm going to get all that done, and then we can talk about installing the rod, the piston and the rod. With the gasket made and fitted to the bearing plate, so it's all set to go, I just want to give one point of interest. Where I had said the valve design on a Clinton is superior to the Kohler earlier in the video, here's a point of interest where the Kohler design is far superior to the Clinton, and that is the oil seal that goes in the bearing plate. Now, this is the side of the bearing plate that the ignition bolts to, so it faces that way. This is the interior portion of the bearing plate where the crank bearing rides on the race and where the gasket goes. But the oil seal that goes in the bearing plate has to be installed from the inside. You actually have to take the oil seal and press it in or tap it in this direction. Then you install the bearing plate. So over the course of time, when these engines get a lot of wear and tear or the seal's improperly installed, it'll weep. But the only way to fix it is to field strip the bearing plate. You can't, with that, there's like a ridge right there that the seal can be pressed all the way up against, or nearly there. Well, guess what? It's not a diameter on this side where you can pull the seal out. I mean, how stupid is that design? That's really a dumbass design, because at least a Kohler, if the seal should weep, you have the ability or the probability of getting a picky and removing the seal and then putting a new seal in with the bearing plate installed. On a Clinton, you can't do that. You have to take the bearing plate off. Incredibly dumb. But what are you going to do? It is how it is. So what I'm going to do is I'm going to go ahead and install the seal, put the gasket in, put the bolts in, torque it to 150 inch-pounds, and then we'll move on to the connecting rod. Next up is the connecting rod. I do have an NOS rod here. There's the part number if you're looking for it, 4562-500. One thing about Clinton, the 500, you'll see that after most part numbers, it just means that it's a replacement part and not an original part put in a motor. So 4562-500. The only thing we're going to reuse from the old rod is this. This is the dipper, the oil dipper. It's held into place by the rod bolts. We do have a new rod bolt retainer. This one's a little bit rusty, so I'm going to sand it down, clean it all up. Going to pull the bolts off, make sure the rod is super clean. I do have to clean the pin and the pin retainer clips. The piston itself, the new rings are on there. So I'm going to go ahead, do all that, and then I will chuck the piston and the rod into the bore with the ring compressor. You've seen me do that just recently, at least 3 times. No difference, just going to get it done, get it in there, and then we'll move on. Rod is installed, everything looks pretty good. There is unfortunately a little bit of a tight spot for some reason. When it rotates, I did rotate it 2 or 3 times just to make sure everything works. And there does feel to be a little bit of a tight spot. I looked around on the rod. One thing I did notice, there's really very little, if any, side-to-side movement on the rod, on the crank journal. So I don't know if that's an issue. I know the crank spun nice and free and smooth once I put the bearing plate on. I mean, it spins fine. It's just got a little bit of a tight spot, or at least it feels that way. I'm gonna leave it, and we'll chalk it up as part of the break-in period. There's no scratches in the bore from the ring set, so that's in there. The other thing too, the rings are pretty tight. In other words, you could feel and hear the rings sliding up and down the bore. So as of right now, I think we're in good shape. I don't foresee any issues. I did dribble oil all over everything in general. I need to clean the oil pan. We're going to clean up this surface, clean the bolts, and when you see it next, the oil pan will be installed. The long block is together. The 2 oil pan bolts were set to 350 inch-pounds as per the manual. 200 inch-pounds on the head bolts. I will do a retorque after I start the engine up and do one good solid heat cycle. We need to do the breather, the carburetor, governor, and ignition system. But that is for another video. I just went ahead and put the long block together. I hope you found this interesting. A little bit back to my roots. I kind of did Clinton engines at the beginning of my channel, but every once in a while a Clinton does come up. So I hope you found this one interesting. In the next video, we'll do those last little tidbits and we will get this thing on the engine stand. Thank you very much for watching. Please like, share, and subscribe. And if you would like, please leave a comment below. And until the next video or the next crazy project, you have a great day.